Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle, and it's called, take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Happy Threes and Buttercream by Marty Sears, and here are the rules. Normal Sudoku rules apply, which means fill every row, column, and box with the digits 1 through 9 without repeats. Every cell in the grid belongs to a square/rectangular region to be located. Each region contains a cupcake. The digit on the cupcake indicates its region's size. Digits may not repeat in regions. Okay. So every cell in the grid is part of a square or a rectangle. So this cell could be part of, say, this square, or it could be like this rectangle, or it could be like a rectangle like this, or it could be a square like this, or a square like this, right? Every cell is part of a square. We know that for certain. And each region contains a cupcake. So say we had a region like this, right? This contains a cupcake. So every region contains, every cell is part of a region, and every region contains a cupcake. And the digit on the cupcake indicates its region's size. And you cannot have repeats in regions. That's very important. So there are no repeats in regions. So it acts like a killer cage if you know those. And so, for example, if this were the region, this cupcake, the number on this cupcake would be 6 because there are 6 cells in this region. And the cupcake contains the region's size. So that's how regions work in this. We also have digits separated by an x summed to 10. So for example, if this was a 2, this would have to be an 8 to add up to 10, because these two digits add up to 10, because the x says they add up to 10. And the final rule is every region has 4 different corner cells, none of which are allowed to contain a 3. Okay, so for one thing then, that means that you cannot have... Okay, every region has 4 different corner cells, which means you can never have a region that is of length 1 or of width 1, right? Because you have to have 4 different cells in every corner, in every region, right? 4 different corner cells, and none of them can contain 3. So say we had a region here. None of these corner cells could contain a 3, and they all have to be different. Right? So these are all different cells, obviously. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, the first thing so that basically means every region then is either a 2 by 2 space, a 2 by 3 space, a 2 by 4 space, or a 3 by 3 space. And those basically are then what? The sizes must be either 4, 6, 8, or 9. Well, we have 2 here that add up to 10. The only 2 possible would be 4 and 6. So we have 4 and 6 here. That means the 4-6 pair eliminates any 4 and 6 in the rest of the row. So these must be 8 or 9. Well, this can't be 9, because if this were 9, the problem is it would always include this cell, right? Because any 3 by 3 square you draw with this cupcake always would contain this cell. So this can't be 9. This has to be 8, which makes this a 9. This 9 means that it's 3 in one direction, and it cannot contain the 8, because you can't. Each region contains one cupcake. And if it were the same, if you did have two cupcakes, the problem is they would be the same number, which is not allowed. So this is the same region, and we could go up or down. We're not sure exactly which. Or it could go both. So this is part of the same region. These two must be part of the same region. So we'll make that orange. And these two must be part of the same region. And the reason why is these are all 2x2s or 2x3s, right? So either way, you have a 2 here and a 2 here. And it goes 2 here or 2. It cannot go here because you can't have duplicates here. So this one has to go down. So these two are orange, and it could extend further, but we're not sure. This 8 is a 2x4, and it cannot go up to here, so therefore this is always part of it. And it actually has to specifically go these 4, because it can't go extend to here. This can only be part of a 2x2, and therefore it has to be here, right? Because it can't extend to this one. This could be part of 2x2, 2x3, so this is 4. This cannot be a 2x2 then. It has to be at least 2x3. So that's at least those. This can't be a 2x2. So this has to at least go up here, right? Because it's blocked by this one to being this 3x3 region. Okay, so this is specifically either a 2x2 or 2x3. The problem is if this becomes a 2x4, say it's there, what region can this be part of? That's a square or rectangle that has two cells at least. It can't be part of anything. It can't be part of this orange. Can't be part of this. So this must be the pink. So this must be 2x3. This has to be 6. 3 cannot be in any of these corners. So 3 can't be here. 3 can't be here or here or here. Whereas the 3 in box 9, it has to be here. Right? Because 3 cannot be a corner cell. And these are corner cells. This is a corner cell. All of these are corner cells. So this has to be a 3 here. What about box 6? These are corner cells, so they can't be 3. These are corner cells, so they can't be 3. But these are, These are corner cells. This is a corner cell. So 3 could be any of these 3. These are corner cells. These are corner cells. So none of those could be 3. So one of the 3s is here. This has to be a 2x2 at least. So all of these are taken. I'm going to make that blue. It could be 2x3 here, or it could be 2x3 here. So this cannot be 9, because it can't be a 3x3. This can't be a 3x3 either. So this is 4, 6, or 8. This is 4, 6, or 8. This can't be a 3x3 either, so this is 4, 6, or 8. We don't know. This is either 6, 8, or 9. And this could be 4, 6, 8, or 9. What cell, what region is this part of? It cannot be part of this one, so it must be part of this. So this is at least 3 this way. Similarly here, what region can this be part of? Can't be part of this because this would be 10. This would be a 2x5, which adds up to, which has 10 digits, which is not allowed. So it has to be part of this region. So we're going to make that there. This is at least 3 here. It has to go at least 2x3. So this is at least a region. These both have to be part of this region. This can't be part of red, can't be part of orange, can't be part of yellow or pink here. So this has to be part of its own region. So this is not 4, it's 6, 8, or 9. This could go down. If it went down here, though, what's the problem here? If it went down, the problem is this could no longer form a rectangle, right? So this has to be the 4. This has to be 4, and this has to be 6, which means this is at least a green. This is done. Okay, so let's look at boundaries. This is a bound. We're in the center. We need to do edge. This is a boundary. Let's just draw the entire boundary. This is a boundary. This is a boundary. This is a boundary. And this has to be a boundary. So this is a boundary too. So one of these is 6 and the other one is 9. Well, no. This could be 9 and this could be 6 or 8. This is only 6 or 9 because it has to be either here or here. This could be 8 this way. We don't know. This cannot be 6. So it's either a 2 by 2 area or 2 by 4. This has to be its own separate region because it can only connect with that. This must connect with this, so we have that region. I'm gonna make that yellow. This cannot, or this could connect this way. These can only be part of the blue. So this is either 6 or 9. We're not sure which. If it's 8, it's 8 this way, which would force this to be a 4. And then this would be 6 here. This would be 8 here. And this would have to be 9. So this can never be part of the red, right? If it's part of the red, this would not form a rectangle to add up to 8. And it can't be 4 then, obviously. So either way, this has to be green. Because it cannot be part of red, it can't be part of blue. So it has to be... So either this is 4. I guess this could be 8 here. But what are these two cells part of? They have to be part of this region here, right? It can't be part of blue, can't be part of pink, can't be part of this blue. So these have to be yellow. Sorry, this could be 9 also. I don't know why I had it 4 and 6. It's 4, 6, 8, or 9. It could be 9 here. Right, I didn't see that. But yeah, this is 4, 6, 8, or 9. So this has to go this way. This cannot be yellow, so this is either blue or red. We're not sure which. So therefore, this is 4, 8, or this is 4, 8 here. This is specifically 6 or 9, and this is 6 or 9. So this is blue or yellow. Well, this has to be 6, and therefore this is the region. Well, that means this has to be part of the red. So therefore, this is an entire region too. So that's done. Therefore, this is size 8. This must now be part of the green region. So this is a full 9 by 9. So this is 9, which makes this 6. So therefore, this can't be part of the yellow region. It must be part of the blue region. And this must be 9. And we have all the regions now. This is a region. Actually, we don't. One of these is not, obviously. Now we check where the 3s can be. 3 cannot be here, 3 cannot be here, but 3 could be any of these. 3 can't be here, 3 can't be here, but 3 could be any of these. These can't be 3. These can't be 3. This can't be 3, that's a corner. This is a corner, these are all corners. This is a corner, so one of these two is a 3, which means this can't be 3. 3 cannot be in any of these. Okay, so this is a corner, this is a corner, this is a corner. And these two are corners. Where's a 3 in row 9? These are corners, so they can't be 3. This is a corner, and this is a corner, so those can't be 3. And these can't be 3 because of that 3, so this must be a 3 here. So this is 3. Well, 3 has to be one of these two, and this is a corner, so this can't be 3. This is 3, which means this can't be 3, which makes this a 3. So one of these 3 is a 3. Okay. 3 cannot be either here or here. And this is a corner no matter what. So 3 cannot be any of these cells. It cannot be that one, so it has to be one of these 3. But it cannot be here. So therefore, it must be here. So this is a 3, which means this can't be 3, and this can't be 3. So one of these two is a 3, which means this can't be 3. So one of these two is a 3. These can't be 3 because of this 3, so this must be a 3. Which means that can't be a 3, so this must be a 3. Obviously, if this is a blue, this would not be 3, so this would have to be a 3. Let's see. 8 has to be, okay. This purple cell has to have an 8. 8 cannot be here because of the 8 in this box. So 8 has to be one of these, which means this cannot be 8. So therefore this is a 4, which makes this an 8. So this has to be all red. And therefore this is blue, and here is the boundary here. So this can no longer be 3 because it's in a corner. So this must be a 3, which means this can't be 3, which makes this a 3. Now 3 adds up with 7 to add up to 10, so this has to be 7 here. This is 4, this is 4. This can't be 4, so where's the 4 in row 6? It has to be here. So this is 4. What other 4s do we have? One of these two is a 4. This can't be 4, and this can't be 4. So in this green region, where's the 4? It must be one of these two. So since one of these two is a 4, one of these two has to be a 4. There cannot be a 4 here. There can't be a 4 here. So where is the 4 in box 7? It has to be one of these 4, which means this can't be 4, which means this is a 4. 4 can be any of these. This cannot be 1, 9, cannot be 3, 7, and can't be 4, 6. So this must be 2 and 8. This can't be 8 because of this 8, so this must be a 2, which makes this an 8. Where is the 7 in column 7? Can't be any of these cells, can't be the filled-in cells, so it has to be here. So this is 7, which makes this a 1, 5 pair here. The remaining cells here now are 2, 4, and 6. Obviously, this can't be 4, and this can't be 6. So one of these two is a 6, which makes one of these 3 a 6. But this can't be 6 because of the 6 already in the region, so this has to be the 6. Well, that means one of these two is a 6 because we have a 6 here, eliminating those 6s, and 6 here, which eliminates the 6 in this column. And this can't be 6, so this must be a 6 here. The 6 in box 8 cannot be here because we already have a 6 in that region, so it must be here. So this is a 6. And we don't know about this. Okay. We know one of these two is a 6. This has to be 4 and 9 because the remaining digits here are 1. We already have a 3, but it's 5, 6, 7, and 8. So this must be 2 and 9 here. So 2 and 9 are here. 2 and 9 can only be add up to 10 with 1 and 8. So this is 1 or 8. This can't be 9, so this because of this 9, so this must be 2, which makes this a 9, which makes this a 1. The remaining digits in row 5 are 1, 5, and 7. This can't be 1, so this is 5 or 7. This could be 1, 5, or 7, and this could be 1, 5, or 7. Remaining digits in column 4 are 1, 5, 7, 8. So this is 1, 5, 7, 8, and these are 1, 5, 7, 8. But this can't be 8 because of the 8 in the region. This can't be 7 because of the 7 there. This can't be 5 because it doesn't add up with any digit to add up to 10. And if this is 1, this would have to be 9, which is not possible. And if this is 7, this would have to be 3, which is not possible. So this must be 8, which forces this to be 2. This can't be 8. We have a 1, 5, 7 triplet in box 2, which eliminates 1, 5, and 7 from the rest of the box. So there has to be 2, 4, 8, and 9. So these are 4. This is 2, 8, and 9 in the rest of the box. But this can't be 9. So now we have a 2, 8, 2, 8 pair in the box, which eliminates 2 and 8 from the rest of the box. So this cannot be 2 and 8. Therefore, that forms a 4, 9 pair there. We also have a 1, 5 pair in row 2, which eliminates 1 and 5 in the rest of the row, which means the rest of the row is 2, 4, and 9. And this cannot be 2 or 4, so this must be a 9, which makes this 2 or 4. Where are the 9s? The rest, this cannot be 1. It has to be 1, 5, and 7 remaining. So this is 1, 5, or 7, but it can't be 7 here. This is 1, 5, or 7. This must be 5 or 7. The remaining digit here is 5 or 7. So that means we have a 5, 7, 5, 7 pair in box 5, which eliminates 5 and 7 in the rest of the box. So this is 6 and 8. This is 6 and 8. And this cannot have a 7 in it. So where is the 7 in column 6? It has to be here because this can't be 7 because of this 7. So therefore this must be a 7, which makes this a 5, which makes this 7. This can no longer be 7. The rest of this is 1, 2, and 5, and this can't be 2. The rest of column 3 has to be 7 and 8, right? And yes. So this is 7 and 8, which means this can't be 7, this can't be 7. Well, where's the 7 in box 6? Can't be any of these cells, can't be the filled-in cells, can't be this one, so this must be a 7. So this is 7, which makes this not 7, so this is 8, which makes that 7. This 8 means this can't be 8, so this is 6, which makes that an 8. Remaining digits in row 4 are 1 and 9. This can't be 9 because of that 9, so this is a 1, which makes that a 9. This 1 means this can't be 1, so this is 5, which makes that a 1. This is the remaining digit is 6. The remaining digits here are 2 and 5, but they still could be 2 or 5, so this is 2 or 5. Remaining digits in box 7 have to be this 4 with 7 and 9. This can't be 7, so this must be a 7. So this is 7, which makes this a 4, 9 pair. Where's the 9 in row 7? Cannot be here. Can't be any of the other places because we can't have a 9 in any of those. So this must be a 9. This can't be 6, so this has to be 2, which makes that a 4, which makes that a 6. This 2 means this can't be 2, so this is 8, which makes that a 2. This 4 here means this has to be a 2, so this is 2, which makes that a 5, which makes that a 2. This 9 means this can't be 9, so this is 4, which makes that a 9. And this is just normal Sudoku. This 9 means that can't be 9, so this is 4, which makes that a 9. One of these is 4, but this can't be 4 because of that 4, so this must be a 4. We have 1, 5, and 7 remaining. This can't be 1 or 5, so this is 7, which means this can't be 7. So this is 1 or 5. This is 1 or 5. We have a 1, 5, 1, 5 pair in column 4, which eliminates 1 and 5 from the rest of the column. So this must be a 7. This can't be 1 because of the 1 in the region, so this must be a 5, which makes that a 1. This 5 also makes that a 1, which makes that a 5, which makes that 1, which makes that 5. This remaining digit is a 5, so this can't be 5, so that's a 1, which makes this 2. This 1 makes that a 5. This can't be 1 or 2 or 5, so this is 1. That leaves a 2 here. This 1 means this is a 5, which leaves a 1 there and an 8 here. And that's the solution. Funny thing with no 3s in the corner, because this was actually a happy birthday puzzle for that Marty set for another setter called Ratfinks, and I guess she likes Buttercream, and she doesn't like 3s in the corner, which is why all the 3s are not in the corners of anything. I guess it's in a 3 of a box, but that doesn't count. Anyways, that's fun. That's a fun puzzle. The logic flowed very well, and it was a very cool puzzle just in general. So I enjoyed it, and I hope you enjoyed this solve. And I'll see you next time on Frank Puzzles. Take care.